we're going to look at 9C, which is all about flow problems, as in flow through a network. Now, the first concept we have to get our heads around is maximum flow. Looking at the diagram on the screen, you have a section of network where two components are connected at a vertex. Going into the network at that point is 25 litres a minute, coming out is a capacity of 58 litres per minute. But the maximum flow through this section of pipe, clearly I hope, is whatever that minimum number is, 25 litres a minute. So it doesn't matter how big the second capacity is, won't go more than 25 through that vertex. And the other way around applies as well. You've got 58 going in and 25 coming out. You still won't have more than 25 going through that network. So that's the concept of maximum flow. If pipes of different capacities are connected one after the other, maximum flow through the pipes is what they call the minimum capacity of the individual pipes. Next concept is the concept of source and sink. Now, any network flow problem, the flow has to start somewhere and has to finish somewhere. Now, we call where it starts the flow, and where it finishes is the sink. And this is normally drawn left to right. In this case, the source is at S and the sink is at T. Right, another concept, the concept of cuts. Now, those red dotted lines are several cuts through the network, and the point being that you are cutting off completely the source from the sink. So C1 clearly cuts off anything going through to the rest of the network, and C6, doesn't matter what happens before then nothing can get to the sink. So this has a number of applications. If you wanted to shut off in the network, whether it's water or gas or sewage, in an emergency, you might look at where you have to completely shut the network, and there's obviously a number of possible places where you could shut off the network completely. In wartime, the defense forces of a country, or the attacking forces of a country rather, will look at ways of completely cutting off, say, Berlin from Leningrad, such that nothing can get through. And this is in fact what happened in the Second World War. Right, we have to calculate the capacity of a cut by adding up all the numbers that it cuts through, and this is where it gets a bit tricky. So C1 is a cut in two places, 8 plus 11 making 19, and the last one, C6, is a cut making a total of 9. And interestingly, it says that C5 is 3 plus 3 plus 1 equals 7, when in fact C5 looks like it's cutting through a 3, a 5, a 3, and a 1, which is a good deal more than 7. This will be explained as we proceed. So just to clarify, a cut is through all the components of a network so that the source is shut off from the sink. In this case, it's 3 plus 5 plus 1. Now, even looking at that diagram, you'd think that was the minimum cut, but apparently it is not. It is not 3 plus 5 plus 1 is going to be less than that. And it says this one is. Now, if you look at what we're doing, there is something called backflow in there. So B to A is what we would call backflow, and it says it's 5, but where's that 5 going to come from? It's obviously going to have to come from CB, which is 3. So in fact, BA is not 5 at all. So let's see how we actually work that out in detail. Now you start more or less going from left to right and see what you can find out about the inflow and the outflow of each vertex. To find the maximum flow through a network, at each vertex adjust inflow according to its outflow and outflow according to its inflow. As far as possible, you move, generally speaking, in the direction of source to sink, but you might have to go back and change numbers more than once. Now I've started this one here, I've started looking at point C. I can see there's 11 going in, but there's only 3 plus 1 going out of C, which means that only 4 in fact can go into C, and so I crossed out that 11 and made it a 4 into C, and so I crossed out that 11 and made it a 4. Another step, I'm looking at B now. We've got 3 going in and 5 going out towards A and T. Now if there's only 3 going in, those numbers have to be reduced to a total of 3. It doesn't matter whether you do 0, 3 or 3, 0 or 1 and 2 or anything else you like. As long as the inflow equals the outflow, it'll all work out in the end. So I've changed BA to 0 and BT to 3. Now I've changed SA to 3 because AT is 3 and we can only have 3 coming out of A, so we can only have 3 going in. And I think that is now all the changes that you need to make, because it looks like there, and this is what you have to prove, that all the cuts are now the same and 7 in this case. 3 plus 3 plus 1 is 7, 3 plus 4 is 7, and so on. And in fact, if you don't get all the cuts the same, or if you don't finish all the cuts, then you haven't actually proved that you found the maximum flow, which is the minimum cut.